This is straight off of Blackboard. This is your little project that you're going to be doing for in-class project 1. Now, notice that it gives you a little bit of information, and most of the time when you're reading a program problem, or what we call a specification, you need to look at it very closely because it's going to give you a lot of information here that's going to answer your questions before you even have them. So get in the habit of reading these things and understanding what they're asking for before you start getting confused and trying to do something and go down the wrong rabbit hole. All right? So let's look at this. Number 9. If my age and your rate are numeric variables, what did I just tell you? It just said that these two names are numeric variables. So they point to a memory location of type number. That means that those variable locations can only hold numeric types. You can't put a string memory value into a numeric or vice versa. So it's apples to apples. If you've got a numeric data type, then you have to assign into that variable location a numeric data type. So if you got a numeric number or numeric variable and you try to put a string character in that memory, it's going to hose. It's not going to work. You can't do that. So remember, apples to apples, oranges to oranges. All right? So back to the statement. If my age and your rate are numeric variables, which that tells you that they are, and depth name is a string variable, well, guess how many variables we have here? 1, 2, 3. My age, your rate, and depth name. That's all we know at this point, other than the fact that we know that these two are numeric, and this particular variable is of type string. Now remember, you can't assign a string into a numeric and vice versa. They have to be the same. So based on what they just gave you here, which of the following statements are valid assignments? Now, they just mean, are these types matching, or is the assignment set up right, and so forth. Now, you can go back to this if you're not sure what types these are, if you can't remember that. If a statement is not valid, explain why not. All right, so we've got A through Q, and all you have to do is just put this in a Word document, upload it through Blackboard, and I've got other videos to show you how to do that if you're not sure. So I'm going to kind of keep this open. I'm going to minimize this and sort of work these together maybe. Try to anyway, get as close as I can to doing that. All right, so this is in-class lab 1. I've just got a Word document open here. Now let's look at A. Based on the information given, my age assignment 23. Well, what's the rule? Again, when you see an assignment operator like this and the compiler sees that, it knows that there's supposed to be one variable, one value on the right over here of that assignment operator. The value over there is 23. Okay? Now, that's called a numeric literal, meaning it's just the actual number 23. It could be another variable name over there. Now, that's fine if this is numeric, but what if we wanted to assign a string into a string variable? Well, you delineate characters. They can be any character on the keyboard, 431, my name, whatever, with opening and closing quotes. That tells me that that particular value right there is of type string. This tells me, because of the absence of the quotes, that it is numeric. All right. Now, what data type is my age? My age and your rate are numeric variables. This is called a literal constant, and it is a numeric literal constant. This means literally typed in. So, if this is numeric and this is a numeric variable, is this a valid assignment or not? You're putting a number into a numeric memory location. So, is this valid or not? Of course it is, because I'm putting a number into a number. So I'm just going to type valid for A, and then come down here and we'll do B next. Okay. My age assignment, your rate. These can hold any value in memory. We don't care, but you're going to take, by using this name here, which is that your rate is numeric, that name points to the starting address of memory, right? So if I use this name, it's the same as pulling the value out of that and sticking it right here. So I'm taking what's in your rate and pushing it over into the memory location pointed to by my age. Both of these are numeric variables according to the verbiage here. So that is a valid assignment, because you're taking a value stored in a numeric variable and copying that value into another numeric variable called my age. So that's a valid assignment. We don't have to do anything with that. Okay. My age equals depth name, or my age assignment depth name. What's the rule here? You can only assign like types into variables of same type. So What type is department name, dep name? Well, if you come up here and look, it's of type string, is it not? Okay. What type are we trying to assign it into? Numeric. That is not a valid assignment because that's apples to oranges. They both have to be the same type. So that's invalid data type, or incompatible, however you want to do it. I'll understand what you mean. Okay, so now on to D. My age equals dep name. Well, what did I tell you about string literals? What tells the compiler and you that this is a string literal? The fact that it's delineated with opening and closing quotes. It's wrapped, surrounded by those. Now they're trying to fool you here a little bit by using dep name in here. That's not the same thing as that variable name. This is just 4, 5, 6, 7 characters. DEP, capital NAME. That is a constant. That's a numeric constant. So we're saying this is a string. We know it is because of the quotes. And we're trying to assign that into a memory location pointed to by the name my age. What type is my age? My age is numeric. This is string. This is numeric. That's not valid. Invalid data type. Types, I should say. Okay. All right. Now, E. 42 equals my age, or 42 assignment my age. Now, unlike a mathematical statement where you can have, let's just go up here real quick and type this in so you can see it down here. In math, I can have X or Z equals Y. All right. That's a test for equality. If the value represented by Z and Y are equal, then this is true. If they're not, you draw a line through it, it's false. You can also type it like this. Okay? It doesn't matter which direction. You're comparing the one on the left to the one on the right. That's not what we're doing here. We're making an assignment, okay? You can't assign something into a literal constant. That is a numeric constant right there. You can't take what's at my age, which may be 15, and stick it into a literal constant like that. It will not work. It has to go the other direction. So the place you're going to assign it to has to be on the left of the assignment operator. The value that you're going to put in there has to be on the right. So what's wrong with this? It's an invalid assignment because the assignment is backwards. All right? Now F. Okay, your rate, assignment operator 3.5. What data type is your rate? Well, we know up here by looking at this verbiage that both of these are numeric, so your rate is numeric. And what do we have over here on the right of this assignment operator? We have a numeric constant, 3.5. Both of these are numbers. So you can take 3.5 and stick it in the memory location pointed to by your age, and that's a valid assignment. There's nothing wrong with it. Whoops, valid. All right, G. Your rate equals my age. All right, assignment my age. These are both of the same data type, are they not? They are, both numeric, so there's nothing wrong with that. What it'll do is it'll take whatever stored in the memory location pointed to by that name on the right and stick it in the memory location pointed to by the name on the left. They're both numeric, and they'll both have the same value after this, so that is a valid assignment. Now, H is next. Your rate equals department name or assignment department name. What data type is your rate? Well, if you look up here, you'll see it's numeric. What data type is department name? You look up here, it's string. You can't put apples into oranges. That is invalid because it's invalid data type or mismatched data type. All right. Later on, you can convert those if you need to in other languages, but for now, that's invalid. I, 6.91 equals your rate. Well, they're both numeric, but the problem is this assignment is reversed. So that's invalid because the assignment is backwards. Okay. Oh, that's I, sorry, J. All right, here's another one. Dep name equals personnel. Well, it looks like we got two variable names here. However, they have not given us, they've only given us 3 variable names, so we don't know what this is. It's not a string constant. String literal because it's not wrapped in quotes. It's not a variable name because they haven't given us any of those. There can only be 3 based on what we know. So there, for different reasons, this was invalid, but mainly because the compiler doesn't know what personnel is, or it's thinking it's a variable name and it's trying to put that in here. So that's just invalid because one variable is unknown. We didn't declare it, they didn't tell us about it, so that's invalid. K. Department name equals personnel. Well, what data type is department name? Well, if we come in here and look, we'll see department name is of type string. So we have department name, assignment operator, and what is this? Well, this is a string literal because it's wrapped in quotes. It's perfect. It could be any characters in there. It doesn't matter. It's a string literal. Just so happens to form a word. It could be ABC 1, 2, 3, 59, whatever. So since both of these are a type string, it takes the string literal and sticks it in the memory location pointed to by the name on the left, which is dep name. It's also a string variable. So we have apples to apples. That's valid. L. Dep name equals 413. You should be getting the hang of this by now. What data type is dep name? String. What is this? Well, it's not a string literal because they have quotes in it, so that must mean it's a numeric literal or numeric constant. So you can't put a number in a string. You can't have apples to oranges, so that's invalid because invalid data type. Okay? You with me? M. Dep name of type string, remember? Assignment operator, quote 413, close quote. That is a string literal or constant. So that's going to be pushed into a string data type. So it's apples to apples. That's perfectly valid. N. Dep name equals my age. Well, that's an easy one because this is of type string and this is of type what? Numeric. You can't put apples into oranges or vice versa. That's invalid because they are invalid data types, or they're mismatched data types, however you want to write it. All right. O. Dep name, assignment, your rate. Again, this is a string variable versus a numeric. You can't take a numeric value and stick it in a string. It won't work. So that's invalid data type or types. All right. P. 413, assignment dep name. Well, there's a couple things wrong with this one. Let's just examine the types to start with. What type is this? It's not wrapped in quotes, so that means it's a numeric value, numeric literal constant. This is of what type? String. All right, well, first of all, we got mismatched types, but that's not even the worst of it. Even if this were in strings, like this one, it would still be incorrect because the assignment is backwards, so that's invalid. Right, is backwards. Last one is Q. I think I've already answered that one for you. It's just like P, only the data types match. This is a string literal and this is a string variable. The problem is they're reversed. The assignment's backwards. You can't go from one side to the other. The variable name has to be on the left. You can have two variable names, but you can't have a string constant over here because it's a fixed memory size. So that will not work. Assignment is backwards. All right. Got a misspelled word. All right. So now you've got your file here, and you can save it to your jump drive, which we talked about earlier, or talk about in another video on how to set up your jump drive.